One of the waves that we are interested in studying in this course is what we call sound waves. To understand more about sound waves, we need to think about the way we produce sounds. Okay, there are lots of ways we produce sounds, but the simplest way to understand sound production conceptually is the way we produce sound through a speaker. If you look at this animation here, what we have, the speaker is made up of a membrane that's going to be moving back and forth through magnetic forces that are going to either attract it or repel it, producing this back and forth motion. As it moves back and forth, it's going to push air molecules in or out. And by pushing these air molecules, it's going to produce sound. It's the push and the pull on these air molecules is what's going to produce sound. In other words, what the speaker is doing is actually producing compression waves. What we call the type of wave is longitudinal waves. So what the speaker is doing is compressing and expanding the air molecules. And here we have a diagram kind of representing air molecules as these black dots. And you see the speaker, or in this particular case, this piston, is kind of compressing the molecules together and pulling them apart. Like all waves, it's not the air molecules that are going to move, and you notice here are the red dots for illustration. It is actually the energy associated with the wave that's going to travel, but the molecules are going to just oscillate back and forth around their position. Now, longitudinal waves, in particular sound waves, have all wave characteristics. What do we mean by that? A sound wave is going to have an amplitude, which is the maximum displacement of the particles of the medium from the equilibrium point. Or in this case, since we are going to talk about expansions and compression of air, it's actually change in pressure in the air. So we can think of the sound wave as a pressure wave. And then, if we do so, then we can think of the amplitude as the change in the air pressure, instead of thinking of it in terms of the displacement of the particles. The wavelength is going to be the distance from crest to crest, like for regular waves. The period, like for regular waves, the time it takes consecutive crests or troughs to pass through a point. The frequency is the number of waves passing by a particular location in any given time. Okay, it is the inverse of the period. It's number of cycles per second. Now, how fast then the wave is going to have a speed. The speed again is going to depend on the medium. The speed is related to the frequency through this expression, frequency and wavelength. But then its dependence on the medium is slightly different than the equation. If you recall the wave on a string, we are told that it's going to be tension over mu, mass per unit length. In this case, the velocity is related to the bulk modulus of the medium over the density of the module. It's square root of the bulk modulus over the density. Also, for sound waves or any longitudinal waves, we can talk about reflection, refraction, interference, resonance, and standing waves. They have all wave characteristics as all other types of waves.